So good morning again. My name is Alex Appiaje. I'm the program leader for BSc Civil Engineering. So today I'll be hosting this session, trying to introduce you to our programs. We have several programs under Civil Engineering. We have BSc Civil Engineering, we have B-Eng Civil Engineering, we have M-Eng Civil Engineering. So and then we have construction management. So I hope if you are joining us today, you are hoping to join us, to join one of these programs. So I've been here at UEL for about 4 years now, and I teach highway transportation. So what I plan to do is to go through some of the things we do and some of the things you will be doing if you join us in terms of the modules you'll be taking, the courses, some of the software you'll be exposed to, and more importantly, what you'll be doing if you graduate from us as a civil engineer. So this taster session, usually we do this in our labs, and in the past we have enjoyed welcoming people to our labs. We have a very extensive lab. That's one of our biggest advantages, because we have large labs. We are able to run most of our tests in person, not models. Even though I'm going to show you how some of the software we use, we also have very practical work that goes on in some of our civil engineering labs. And so I'll be introducing the labs to you. What you are seeing here is a group of students who are now with us about a year and a half ago. I would say 2 years ago, I was hosting them on a weekend. Like today, they were building bridges and other structures, and we had a fun competition. But I hope to make it as fun as possible. The whole idea is for you to know how we teach, and then for you to appreciate some of the facilities we have and how we prepare you for your future career. Okay, so we are located in East London, in one of Europe's largest regeneration areas. So if you come to campus, or you've already been to campus, you see that it's a very welcoming campus, surrounded by most of the modern infrastructure you have. We have the city airport, a lot of the transportation modes you'll be dealing with as a civil engineer or around us. So we have a living lab that help us to educate our students to be among the best in the world. We work in close partnership with employers. We have an industry advisory board that membership are from reputable companies, civil engineering companies, that helps us design our programs to be as practical as possible, so our students get employment as soon as they graduate. And we focus on developing talents of graduates who can find real life, who can solve real life problems and be able to gain gainful employment. So this is where you'll be studying. Most of our civil engineering programs are all located at our Dockland campus. You probably will come through the DLR station, and you get to what we call the North building. Very easy to get around the campus. It's not very large. The buildings are named in such a way that they are easy to recognize. So you come through the north, you have a north building facing, you have east building, west building, have the library, main library, we have where our labs are, knowledge dock, we call it, and you have a very rich experience once you join us, and I hope you can join us to come and enjoy some of the facilities we have. Now, I didn't introduce myself very well. I just gave you a very brief introduction, but my background, as some of you could tell, I come from Ghana in West Africa. I had some of my education there. I went to the US to study graduate school. I had a PhD from the University of Illinois. I worked in the US for quite some time, and then came to the UK to join my family. And I've worked at University of Nottingham. I've worked at University of Kingston, and for the past 4 or so years, I've been working at University of East London. And my work has taken me into almost every continent on Earth. I've been to East Asia, South Asia. Last year, I was working in South Asia, and I bring all these experience to the classroom. A lot of my colleagues have similar experiences. It's a very diverse unit. So whatever your background, I think if you join us, you are going to have somebody you can relate to, somebody who can inspire you to be your best. Now about today's taster session, as I've mentioned already, we are going to hope that you discover what it will be like if you come to study with us. And that's the main objective of what we want to do. But basically, you look at some of the topics we'll be covering as you spend the next 3 years if you're a full-time student with us. Now, along this, we look at some of our teaching facilities, some of the equipment that we use, some of the software that we use, and you hopefully you get a real life feel for what it is like at University of East London, even though we are doing this virtually. Okay, and my hope finally is for you to be fully prepared to accept our offer and get prepared for your life as a future UEL student. Okay. So just to put some face on those who are in our department, you probably have met the dean this morning, Dr. David Tan, our head of department, Professor Fawad, and I'm the program leader. We have a lot of program leaders. They all couldn't join us today, but we have, as I said, a very diverse set of professionals, all highly educated and highly experienced, who will guide you through your education here at UEL. Okay. So we have what are called module leaders. These are the courses you'll be taking, and each module will have a module leader, and these are your first point of contact. If you have any problems, you can discuss it with them. If they are not able to help, you can approach the program leaders, and if they are not able to help you, you can, in the unlikely event that they are not able to help you, you can even approach our head of department. So it's a very, very structured way that our programs are run. Now, one thing you probably have seen, or somebody might have mentioned, is the way we go backwards to help our students. We pride ourselves of being able to be very inclusive. So we tried our best, no matter your background. Once you are admitted, we want you to feel confident that you succeed in your program. Our programs are accredited, and that means if you join our program and you graduate, after some experience, you can become a chartered engineer or incorporated engineer. Now, this is very important for your career. If you are a chartered engineer or an incorporated engineer, over your life, you'll be earning more than what your colleagues who are not chartered or who are not incorporated engineers will earn. So we help you from the onset to be able to prepare you for your career after school. Okay. So we help train you to be engineers that are able to function effectively in society. Our university prides itself as a career-focused university. So we will give you all the necessary help, provide all the opportunities that will enable you to succeed in your future career as a civil engineer. So in terms of the program structure, in your first year, you'll be doing a lot of modules that are common across engineering, and this is a very common approach to most engineering programs. You go to any universities, you find a similar structure. In my own experience, when I was in the first year, I was taking the same modules with electrical engineers, with mechanical engineers, with chemical engineers, and the reason is at that level, you are learning basic engineering, which is relevant across any engineering module, and it also puts you in a position where you learn from other fields. Civil engineering is a really very broad subject in the past, and if you talk to somebody who was a civil engineer in the 1900s or early 1800s, they will tell you the civil engineer was managing cities. So you have to know something about mechanical, know something about chemical engineering, electrical engineering. So we structure our program in such a way that we prepare you to be that person who is all encompassing, who is very knowledgeable about a lot of things. Nowadays, one of the key things that we are interested in is sustainability, and so we bring in a lot of expertise in even chemical and biological systems to help us train our engineers. All our programs are credit rated, so you see that you'll be taking modules that are 20 credits, 30 credits, things like that, and these are to help you plan and to be able to prepare for your programs. So I don't know, some of you might be joining us at level 3. Level 3 means you spend one additional year, which is equivalent to an A level, to prepare you well to come into a regular program. But in general, those who come directly from A levels or from other advanced certificates, we have level 4, level 5, and level 6. I said our programs are accredited by the JBM. JBM is the Joint Board of Moderators, and these are the ones who control the engineering profession in the UK. And so if you join us, you are sure that the degree you get is recognized. And then, as I said, if you are interested, we help you one day to become a chartered engineer, and you can add some of these letters that you see after my name, CEng or PE. PE is the equivalent in the US, and this carries a lot of prestige. It carries a lot of, it gives you a lot of opportunities, and we hope all our graduates come out and become either chartered engineers or incorporated engineers. So before we start, I just wanted to show a video, a very short video, and this video is important because it will show the main topics you will be taking from year 1 till the 3rd year when you graduate, or if you did if you are doing a part-time, then it will be double that. But this we have key subjects which civil engineers will have to study. One of them is structures, the other is geotechnics. You have transportation. Myself, my background is in transportation, and so I want to draw your attention to some of these. What will happen is, if you join us, we'll be covering some of these subjects. Some of them from the first year, you start an introductory, and then you go to the advanced, and then by the final year, you are able to apply some of the concepts to actually design or to build the type of facilities that we build. So I'm going to share with you a few videos, 2 videos, in fact. One of them is why you want to study civil engineering if you are still not decided, and the other one is the topics, and this is to provide you with a framework so you know what you are going to be in for and how you can plan to manage your program effectively. Now, one of the things for me that is scary is not knowing a plan, or what's this 3 years going to take, what is it going to be like, And so the second video, hopefully, you come out of that video and be able to say, yes, this is what I want to do, and I want to do it at UEL. So let me start video here. If you can't hear the sound, please let me know, and then I'll check the settings. Okay. Any questions at all before we watch our video? Any questions at all, guys? Can you hear me? If one of you can just
To be perfectly honest, I really don't know.
I couldn't differentiate them from any other type of engineers.
Civil engineer.
Can you? And I'm going to don't get.
Yes, I can hear you.
Oh, you can hear me. Thank you very much. So we will go ahead and.
Maybe holding a clipboard, slightly a bit geeky.
They implement government policy on to do with civil building and land matters.
All right, so that's just a flavor of what civil engineers do. In the future, as the video says, what you will be doing as a civil engineer, a lot of the infrastructure would have been built, and your task will be to maintain them and make them more sustainable so that we can continue our current way of life. And that's the challenge new engineers coming up going to face. And so we go through they mentioned some of the topics that I mentioned earlier on, but I want to share another video with you that would actually illustrate this, and hopefully we'll have about 5 more minutes for me to demonstrate some of the software you also be using once you join us. You have some calculations. I know some people don't like all calculations, but what you do at a university, or the way we have structured our program, is we will give you the fundamentals, we will give you the concepts. And once you have the concepts, the software and the computers are the tools that you will use to accomplish them. So we'll look at some of these very soon. And again,
civil engineering is a major to consider if you want to design bridges, dams.
If you can't hear the sound, please let me know and I will stop and adjust the settings.
Dams, roads, tunnels, buildings, railroads, pipelines, and even some civil engineers will work on aircraft or spacecraft structures and more. But depending on what projects you want to work on and what aspect of those projects you want to work on, you will go into certain subfields which can lead to very different career paths. The main subfields I will talk about that you can dive into in college are structural engineering, geotechnical, water resources, and transportation. All civil engineers will take mostly the same classes their first few years and learn the very, very basics of all of these subdisciplines. Then maybe their third, but especially their last year, they will take a lot of electives in the field or maybe fields they want to focus on. So first, structural engineering is about calculating and understanding the forces, strength, stability, and so on within a structure. It could be a bridge, a skyscraper, a landmark, or even a spacecraft or aircraft. Remember, these structures are very heavy and need to support their own weight so that they don't collapse. Now, this subfield is the most math intensive and has lots of physics. All civil engineers will take a class called statics, which is all about the forces and systems that are not moving. In basic physics, you may have done a statics problem, like where does this support have to be for the system to be totally balanced and therefore not moving? You summed all the forces, which equaled 0, and all the torques, which equaled 0. And that's the basics of statics. So if you're looking at the forces within a bridge or truss, well, the same principles apply, but now there's just more to it. The weight is straight down as shown in blue. All the beams exert forces on one another, but the sum of them is equal to 0, and the torque sum to 0 as well, because the bridge is not moving. And it's of course even more complicated than this, but if you enjoy that kind of basic physics you see above, then you'll likely enjoy the statics and physics you see in structural engineering. So that's just a very simplified explanation, but now let's dive into some of the classes they would take. One class that would be important for structural students is a reinforced concrete class. In concrete structures, they reinforce it by putting steel beams in the concrete. We can't see those beams, but here, before construction is done, you can see them sticking out, or you can see a lot of them on these unfinished columns. So why do they do this? Why isn't concrete good enough? Well, concrete alone, once hardened, has low tensile strength, as in it does not handle being pulled very well. However, it's okay with being compressed. But to counteract that low tensile strength, they add steel beams and pour wet concrete, which hardens around them, and then those steel beams have high tensile strength to counteract those types of forces on the structure. So in a lab for this class, you might build the rebar or the steel reinforcing rods, pour the wet concrete onto them, then once it dries, use a machine that holds the beam on both sides, then apply forces in the middle and keep increasing the force until the beam breaks or cracks and starts falling apart. That force being applied is sent to a computer that tells us the loading on the beam so we can collect the data and get the properties that we need. You can take structural dynamics as an elective class. Dynamics is about moving systems, unlike statics. So this is one of the few classes where motion is included. So whether it's wind or an earthquake that shakes a building, you need to know how that motion will impact the structure itself and all the forces within it. I've shown this animation before, but mostly for mechanical engineers, as it's a vibrating system that they could analyze, but civil engineers could get into this as well. They have to make sure their designs can stand up against any type of movement the structure may be subject to. You could take an elective class on seismic analysis, which is specifically about calculating the responses of a structure to an earthquake, or one on bridge engineering, which would be a class on highway bridges, materials used, distribution of loads, and how forces are spread throughout the structure, and so on. Mechanics of materials, like how twisting and bending a beam or column causes it to become internally stressed. Timber structure design, which is about analyzing properties and forces within wooden structures, and much more. See how even if you choose structural engineering, you could still take many different classes from the other structure students? It's a very broad major, but hopefully you really get the idea by now. Lots of physics in this discipline, but mostly statics or forces and structures without movement. In the real world, these engineers often work on the computer and use software for their designs, where that software does that advanced math to determine the forces throughout the structure, like you see here with an office block and its components. You may still have to do hand calculations, but most of the rigorous analysis you learned in school will be left to the software. Now let's move on to geotechnical engineering, and you'll already see how different these disciplines are. Geotechnical engineers are concerned with the behavior of earth materials like rock and soil, but the main focus is soil. This may seem odd, but you'll see how important this is. The structural engineer can do everything right to make sure the building will stand up, but if the geotechnical engineer messes up and you put a structure on soil that can't withstand it or is uneven, the building could fall, sink into the ground, or even lean to one side, probably the most famous being the Leaning Tower of Pisa, which was a result of soil issues. Then they also have to consider the foundation of the structures that are being designed. Like, should they have a shallow foundation or a deep foundation? You may not realize it, but our houses and all the buildings you see have foundations that go underneath the earth to keep the structure as stable as possible by transferring the weight from the structure to the earth. But geotechnical engineers rely heavily on testing. So a lab you might see in college is to go out as a class and collect soil samples around your university and bring them to lab. You would have to classify it, like is it sand, gravel, clay, etc. There are many soil types, and you may have to look at the grain size or how it reacts to water. You determine its water content by analyzing the sample, which will be comprised of a solid soil, water, and air of different masses and volumes. But most importantly, you'll measure how the soil will react to mechanical loading or to different forces acting on it. So you might perform a triaxial test, for example. Too complicated to explain for this video, but essentially you put the soil in an enclosed area and apply a force or load to the top, which pushes down on the soil. Then pressure sensors measure the pressure at different points to see how the soil is being affected. If you imagine a square sample of soil and you add a force to the top, the soil can fail along some weak plane. Basically, the weight overpowers the friction holding the soil particles together, and the soil will start to slide, which is known as shear failure. Its ability to stand up to this is known as shear strength, which is one thing that the triaxial test on the left tests for. And this leads us to what a career in geotechnical engineering could be like. You might be the person who goes out to the field where a structure is going to be built and collects soil samples all around the area for testing. Or you could do testing at the field. One of the most used tests right now in this field is cone penetration testing, where a large truck goes out to the field, which has all this equipment on it, and a cone is pushed into the soil, and the pressure will be monitored by a computer on the truck as it moves through the soil into the earth. Based on the pressure, you can analyze the soil mechanical properties. Or maybe you could work in a lab where you would do the testing on the soil after it's been collected, like I showed with the triaxial test. Or maybe you could work on the computer and input the different types of soil from the various locations at the site, so you can digitally lay out the area that the structure will rest on. So you could be in the field, in the lab, or on the computer. Your elective classes could include geotechnical earthquake engineering, which would be like learning the dynamic behavior of soil as opposed to the structure itself. Then slope stability analysis and how to safely design structures on slopes. An example would be an embankment dam. Analysis of deep foundations, where the structure goes deep into the earth for a stronger support, like for skyscrapers. And of course, there are many more classes. Now let's move on to water resources engineering. This is about the design of systems to manage human water resources. They can work on a water treatment facility, designing dams, pipelines, channels, canals, and so on. Maybe you have to design a storm drain system in the event of a large storm. Where is all the water going to go and how will you get it to the ocean efficiently? Or you could design a canal, which is an artificial waterway to transport water for irrigation, or can be used for ships and boats. Or you could design a culvert that will allow water to flow under a road or trail or some other obstruction. Elective classes you could take include coastal hydraulics, where you learn about ocean wave propagation, submerged pipelines, seawalls to protect human habitation, and so on. Or open channel hydraulics, which is about fluid flow in an open channel as opposed to a closed channel or pipeline. And last is transportation engineering. This is about safe and efficient movement of goods and people. These are the engineers who design streets, roads, highways, railroads, public transportation systems, and even airports. So maybe this engineer has to look at the kind of demand from a new development, whether it's a new stadium in your city, all the way to a new grocery store in a new location. This is going to cause new types of traffic throughout the area. The engineers would try to optimize how the new development impacts existing traffic. They would look at data from other similar places to see what kind of traffic they get, then try to make improvements where possible. It could be simple, like adding a bus stop in the nearby area, all the way to expanding the roadway to allow for more traffic. They could work on the geometrics of the roadway, such as what radius of curvature does an off-ramp have to be for a car going 55 miles per hour so the tires won't slip. Or if they're going up an incline, the driver needs to see far enough ahead of them to stop if there's a sudden obstacle. Or what do the cross sections of a freeway need to be for the lanes and the shoulders to accommodate the amount of traffic that's expected? Or let's say a highway interchange is being designed. A structural engineer would make it stable and design the structure itself, but the transportation engineer would determine maybe how many lanes are needed for the interchange based on traffic, or how the merging should happen to maximize safety. They make sure that the layout is designed to maximize traffic flow and safety rather than the physics of the structure itself. Often these engineers evaluate potential improvements to cities in terms of transportation rather than create a totally new design. As in, you probably haven't had many new highways put into your city in the last few years, but there's probably been plenty of construction, whether it be adding an express lane or a bike lane, etc. So they might not create a new bus transportation system, but they may optimize the existing one. Maybe they take data from how many people get on the bus, how long the bus takes to complete its route, how long people are waiting for the bus, and so on to optimize the route, the amount of stops, and more. Your career will also likely involve a good amount of computer work. You might have to create a layout of the new lane, off-ramp, bridge, or whatever you're designing on AutoCAD, which is a very important software for civil engineers. Or you could use software to analyze and simulate traffic. You could actually lay out the roadway of a city and use collected data of traffic during different times of the day and simulate new additions. Like you could add in a...
Okay, so guys, I think you have a flavor of what you'll be in for, how we have structured our program. As I mentioned earlier on, my own background is in transportation. So at this stage, I just wanted to share with you what some of the software that you will be using looks like. The presenter in this video said AutoCAD. We have a version of AutoCAD that you can actually use to simulate traffic, and that's exactly what I'm going to propose. So in your first year, you'll be covering basics, engineering, basics of engineering, engineering concepts, structures, and statics, fluid mechanics, and so on. And then as you get into your final year, you begin to apply these. And one of the areas you will be applying your skills in will be transportation. So transportation is an option you want to consider. If you did that, you probably will meet me, and I will be your tutor for that. But there are several options you can choose from. As I said, I'll just demonstrate this particular software because it's so common. You might use a version of this for structures, or a version of this. In this case, I'm going to use a version for simulating traffic. So I'm going to share my screen with you with this particular software and just do a very simple demonstration. This I hope guys you can see my screen with some type of a road network on it. If you could, one of you just say yes, and then we can go on.
Yeah, we can.
Yes, yeah, thank you. So this particular software, you probably will be using this, a version of this AutoCAD. Will begin using AutoCAD in the first year, but this version of AutoCAD called InfraWorks, you probably will be using this if you get to the final year. And I've done portions of the design. I picked a road in near Kingston. It's a very, very congested road. And what you could do, as the video said, is sometimes we have to check how our existing system is working and what we could do to improve that. So I have a simulation here, hopefully it will run, but I've picked a junction here, and this junction, you can go to the site and measure the number of vehicles using this particular junction, those who are turning left, those who are turning right. And if you did this over a period of time, you get a representative data. Then you can come back to the lab and do some of these simulations which you are about to see. What this does is it can tell you if the road is congested, if the junction is congested, how congested it is, how long will the queues be, and so on and so forth. So we tend to run some of these simulations just to be able to see what we call what if. What if we change this junction to a runabout? What if we change this, we put traffic signals there, and what this software and the calculations behind it, which you will learn in class, will help you to visualize it. Now, what is important is we will give you the fundamentals. Using computers is just a tool to help you do that. We try to make sure you understand the fundamentals, because one day you probably will come out and say, no, this software is too slow or it's too cumbersome. I want a new software. And we want you to be in a position to be able to do that, to say the existing is not good enough for me and I want a new version. So what you are seeing here is a simulation of this junction. As you could see, is very, very congested in the current state. So what this is telling you is this particular configuration of a junction is not appropriate for the level of traffic that is there. Now, as a civil engineer or transportation engineer, you have options. You can upgrade this by increasing, say, the number of lanes, okay, and that's what we call geometric design. You can increase, you can change this to a runabout, or you can even change this, remove this particular junction if you think the location is not adequate. So you can, why not let everybody go around here, okay? In this particular example, then you don't need this junction. It's probably too short. The lengths are too short, and that's why you are having a lot of congestion. So you can do a lot of simulations, what we call simulation, trying to recreate what is in the field. And we do this for transportation. We do this when you are building, you are designing a new building or a bridge or a foundation or any other civil engineering facilities. Okay, any questions at all, guys? I know you guys have to go to another meeting, and so if you have a question, we can talk about that before.
Just one question, sir.
Yes, go ahead.
Yeah, what's the difference between railway engineering and transportation engineering?
Okay, thank you for that question. So transportation is an all-encompassing term. If we say transportation engineering, we mean railway engineering, we mean highway engineering, we mean airport engineering, and all the other. So a mode of moving goods and services from one location to the other is transportation engineering. Now we use highway engineering a lot because majority of our travel is on highways, but railway engineering is a subset of transportation engineering. So I mentioned that I had some of my education in the US. When I finished my PhD, I was offered a teaching fellow. So I was actually teaching airport engineering for 2 years at University of Illinois. And so it's part of, railway is part of, right now I'm teaching a master's module. It's called highway and railway engineering. Okay, so transportation is just a big umbrella for all these, and there are different aspects. You can do transportation planning. You can do what we call pavement engineering. That means you are looking at how strong the pavement is, the highway is, and there are key differences. If you take a railway, for instance, the way we build it, the way we design for it, because of the way it is loaded, the design is slightly different. But if you compare airport and highway pavement, for instance, the main difference is just the thickness. Airports are usually built stronger than highways. So I hope I've answered your question. I digressed a bit, but that's what it is. Transportation, you can consider that as the umbrella term for all these mode of. Okay.
Thank you.
All right. Any other questions, guys?
When we start our course, so for civil engineering, so we start off with like the basis of civil engineering. Then when do we essentially get the leeway to choose our different courses, and how varied can those courses be?
Oh, okay. So in the first year, if you start your bachelor's or your BEng, the first year you all do common course. These are core. We call them core courses. In the second year, you again do core modules. Then in your final year, you have the options to choose different modules. And so if you wanted to specialize in water resources, there are modules that you take. If you wanted to specialize in transportation, you can choose a combination of modules. So to answer your question, in the final year, you have the options to choose. So what you will see is, if you join us, we classify them, all the modules, either as options or core. Core modules means you have to take them to graduate, and the options are those ones that now some of them we consider every civil engineer should know, so that's why they are core modules. So these are fundamentals, whether you end up being a highway engineer or a water resources engineer. Okay, any more questions?
You know, starting next to an airport, is it not noisy?
Oh, that yes, it's not noisy at all. When I came here, that was my first impression. Say, how can we have an airport here? Because having in my background, for instance, because I was teaching airport engineering, I'm aware of the noise, and in particular in the US, the trouble they go through to insulate buildings and so on. So I was horrified the first time I came in here. I thought it was going to be a problem, but it's not. It's not actually, unless you are outside. It's not a problem at all. It hasn't affected. I would say in my case, it hasn't affected it, even though I came in as somebody who was very sensitive to noise because of my background and my training.
Sir?
Yes, go ahead.
First, like, would we be using FEA software for like structural analysis, like SolidWorks or?
Yes, you have software for structural analysis. Yes.
Okay.
You have a lot of structure. I think you have Revit, you have all the basic. And then one thing I didn't mention, which you would also spend a lot of time on, is surveying, engineering surveying. This is also a basic requirement for all civil engineers. So you'll be doing what we call engineering surveying. Okay. And that's just to make sure you can set up your building to be straight and so very, very important. So this particular video, the second one you watch, I think is a very important video. You can always watch it, rewatch it again, just to, for me, it's easier for me if I know where I'm going, what is involved, and I pick this particular one so that you have, you can put it in a framework, what the whole program is about. Okay. I have put a link on the chat. I think that's your next session. So when we are done and you don't know where you have to go next, I think I was asked to paste this so you can try it if it will work for you. But I'm still waiting if you have any more questions before we end our session.
Can you do an apprenticeship for civil engineering?
Yes. So we have very large. In fact, it has grown so large that now they are almost about half of the total student population. We have a lot of them. Yes.
How would you apply for one? Because I'll start off there and then I don't know what to do after.
Yeah, you have to. If you let me know your I'll put my email here. Send me an email. I'll put you in touch with someone who might be able to help you. But in general, we don't do the placement. We have companies that bring the students, but I'll put you through someone who is more knowledgeable in that area, our apprentice lead, and she might be able to help you. So I'm going to put my email at the end on the chat now. You can send.
I've got one more question.
Yes.
You know how you said that we'll be doing surveying in what is it, the civil engineering course? Will we also be looking a bit into the political, I don't know, like the contract element of civil engineering?
Oh yes, you
like
do.
Legalities and that.
Yes, you do that. So you do contract administration, project management. We call it project management, construction management. Yes, you do topics in that, and you do that in second year, and then in the final year you can also select some options in these areas. Yes, we cover that. So as you could see, civil engineering is very broad. In some countries, we don't even have construction management. You all do civil engineering, and in the final year you can become a construction manager or a structural engineer or something like that. But here, you can focus on construction management from stage one. But civil engineers also take the topics that you have mentioned. We do that. Health and safety, contract management, and so on. We cover all that. Okay.
Yeah, what's the difference between Bachelor of Science and Bachelor of Engineering, Civil Engineering?
So in general, the entry requirements are slightly different. The M-Eng and the B-Eng, you have a higher requirement, and it's usually the guy was talking about structures and how structures are mathematics intensive. The B-Eng version is a bit more mathematics intensive, and so that's the basic difference I would say is between the two. Okay.
So which one would you say is better to do, like for the future?
If you qualify for the B-Eng, I would say it's much easier, especially in terms of getting your chartership. It's slightly easier to get the chartered engineer with the B-Eng. Okay. Right now.
Can I swap from? Sorry, can I swap from Bachelor of Science to Bachelor of Engineering?
No, you cannot. You can't. No, because as I said, the entry requirements are different. So once you are in, you cannot change. But if you want to do the BEng, let me know if you have applied, or you probably have an offer already. But if the offer is for BSc and we want to change that to BEng, somebody can look at it and see if it's possible to change it. It's better to change it now than to join us. If you join us, it becomes difficult to change. And it's all because it's because of the accreditation issues that I mentioned. So we have to tell the joint board of moderators who are on our BSc program and who are on our BEng program, because they are going to give you the chartership or the incorporated engineer status. So that's the. But if you have been offered BSc and you want BEng, or if you have been offered BEng and you want BSc, let me know. If there's a way to change it, I'll advise you on what to do. Okay.
Do you do more like theory work or practical?
Do we come again? I couldn't.
Yeah, do you do more like practical based work or more theory based?
Oh, you mean for the programs? We combine to. We try to be balanced. We do both. I wouldn't say we do more practical than theory, but what we want to do is to give you an education that you can actually use at your website. So in that sense, you can call it practical, but I would say it's just a career-oriented approach to make sure you can fit in as soon as you graduate. So we are fortunate, as I said, we have a large lab where you can do some of the testing. A lot of universities don't have that because, especially those in London, because of the cost of maintaining these facilities, they don't have them, but we do. And then we have the surveying is very practical. We have equipment. We go to field trips that will give you an opportunity to actually use the equipment that you'll be using if you are working in the field. Okay, guys, I think our time is up. So in order not to disrupt your next session, I would like to end our discussion here. Thank you all very much for joining us, and I hope to see you in September. Okay, thank you very much. Bye bye. Yeah, bye. And you have my email, so if you need anything, just let me know. Okay. Bye. Thank you and bye.
Thank you very much, sir. Bye.
Bye.